So how can we write? Writing is as simple as calling a collection and insert. Now, in MongoDB, since we have these complex documents, most of them they have flexibility of schema, so there's no restrictive order on how you set up things. In MongoDB, we provide a DB object document so you can use it to parse in any of your POJOs into MongoDB. Now, this DB object, you might consider it as an extension of map, and you can think about it as a map of strings to objects. And it's pretty simple to use. Basically, what you need to do is just instantiate the object, set the keys that you want to use, go and fetch from your POJO the values that can be accessed by a getter's object, and just throw that information into a document. Once you have that document fully filled, you just need to call the insert function. It's pretty simple. It's not a lot of boilerplate around it. Instantiate your collection, call the bson wrapper, and just fill it in with all the keys and the values that correspond to those keys. You might also want to collect back the write result because MongoDB will always tell you what happened to that write. It is important to understand if the instruction that you just sent actually changed anything in your collection. Let's say, for example, that I'm trying to insert a document which has a unique key index on it, or there's a collection that enforces a unique key. If you try to insert something that invalidates or conflicts with that unique key, or the underscore ID for the primary key, for example, you might want to know what happened to that. Well, the write result object will give you exactly that information. We also like to update things because applications work with live documents and things will change according with the course of the workflow or the stream of information that you are using. MongoDB actually provides a couple of different methods to do that. The first one is the save method. And the save method just does one thing, which is replacing the document that you have in your database by the one that you are throwing in, the new one. Now, be careful about this one because if you are operating in multi-threaded environments and if you are collecting this information from the database, manipulating and calling save on multiple concurrent streams, you're probably going to have some data that will be overwritten by a posterior instruction. So if you have two parallel saves and one changes the value to A and another changes the value to B, this information will be overwritten by the last one. So be very careful about it. The good thing about this method is that it actually uses upsert by default, which basically means that if the document does not exist, it will create one. So be very, very careful about the save. If you just want to do upserts, it's very simple to use, very straightforward. But if you have multi-threaded or concurrent parallelization over a document, make sure you have that controlled. Obviously, we can just basically do normal updates where we can express something that we want to update, like a criteria, and then tell it what we want to update. This is the way that the update method behaves. So in this example here, we are building a query that we're calling query builder for doing that. And we tell it, well, let's query on the name. And I'm providing the name from P. We'll update the result of that query with the new address, for example, that I'm building up, which is a more complex object, not just a string as before. And what I'm doing that is parsing that into a DB object address. That DB object address will be inserted into my normal POJO. And in this instruction, I'm just replacing the object with a full update. Now, this will probably be consuming a lot of bandwidth because we are not doing anything particularly intelligent here in the sense that we're just fetching information from the database with the query and then replacing whatever it matches with it. When probably we don't want to do all of that, we just want to set a couple of fields. And for that, we should use the set operator. This method here, for example, clearly tells us that the only thing that we want to do is set an address. So what we do is we use exactly the same query where we say the name is something. That something we will just call the update, but not the full object that we need to rebuild again. We just need to create the update instruction using the set operator. Now there are several different operators for the updates, and I definitely recommend you guys to have a look to this link over here, the reference operator update, because there's several optimizations that we can do for consuming less bandwidth and consuming a lot less processing power when we do specific sets instead of replace updates. We update data and we also remove data. And for removing data, well, this is nothing as simple as expressing the query of what we want to remove, setting up the criteria, and then just call remove. If we want to understand how many of these documents have been changed, we just use the write result get n that are affected by this remove operation, and we'll get exactly that, the number of removed objects that we just completed. Matching query, we do the get from the basic DB object builder, and then we just call the remove. Now, if we want to just remove all, the simplest thing that we can do is basically just remove everything with an empty DB object. That can be achieved by this instruction, where we call the collection, call the remove operator or remove function, and we just send it a simple remove object which is completely empty.